Can you hear me?
Yes.
Yeah, okay. I was offline momentarily. I lost internet signal here. But now, okay, so let me share the screen again. We are recording. So did you see that, right? I was talking about the holidays when I was offline, right? So here goes Cesar
Yes,
Chavez.
yes.
Yeah, okay. So let's make sure Cesar Chavez Day is the 31st of March. They made this mistake again. Cesar Chavez Day. Mm-hmm. 31st of March. 31st of March is not a Monday, it's a Tuesday. They made a similar mistake back last semester, okay, for another holiday. So someone has to tell that it's not a Monday, okay, it's a Tuesday. So because it's a Tuesday, we won't be able to take advantage of this holiday. There's no Cesar Chavez Day holiday there in my schedule of classes, right? But we do have a spring break. Saturday, April 4th through April 10th. You go April 4th right here. Okay. So one holiday, 2, 3 holidays, right? We have another holiday, 4, Genocide Remembrance Day. Let's make sure that everything is Genocide Remembrance Day, April 24th. Oh, wait a minute. April 24th. April. Oh no, it's a Friday, so we're not gonna benefit from this holiday. Let me change that. Okay, April 24th. Huh. Okay, I know why I put that. I accidentally put that. Okay, I have to fix that. This is not a holiday for us. That's why we should all ensure, right? I'm gonna leave it in blank for now, and then I will fill it up later. And you go. I will highlight it so I don't forget. Another holiday is Memorial Day on Monday, May 25th. May 25th. So how many holidays do we have? 1, 2, 3, 4 holidays in the semester. Okay. So watch for the second version of the syllabus. Some minor corrections here that I made. Any questions about that? For 38. It is 11:38 right now. Let's go for another 20 minutes. Then we have another break. Okay, what I want to cover with you is what I usually do in every course that I teach. For those who didn't take Physics 6 with me, okay, you're going to see something new here that most likely other professors have not covered before. Okay, and is this the building blocks of physics? The building blocks of physics, how physics is organized. How physics is organized. Okay. So you have to keep in mind that there are three concepts, three important concepts in physics that you have to memorize to understand where physics comes from. Okay, so here you go. Those are the three concepts of physics: the basic quantities. Like I said, my students who took physics 6 with me already should be familiar with that, right? If you didn't take, you should become familiar with it now. The basic quantities, which are scalar quantities, by the way. Primary definitions, which are vectorial quantities, and the laws of physics. Okay. The basic quantity is something that we become familiar since we are very little. Okay. At least the four of the basic quantities are something that we are familiar since we are very little. It is the length, time, mass, and temperature. Everybody should be familiar with those four concepts, right? Mom and dad but had told you that about that. You know, here the length of something, you know, be at home in 10 minutes. You know, you go to the supermarket, let's buy X kilograms of oranges, right? We need all those basic quantities to build up the theory of physics, the science of physics. But there are three more that we learn only in college. One of them, here you go, amount of substance, okay? Amount of a substance. That this concept here is introduced in thermodynamics, but is also introduced in chemistry. The unit of amount of substance is the mole. The unit of length is meter in the international system of units. That's what we'll be using. Time, the unit of time is seconds. Mass, the unit of mass is the kilogram. All those three quantities were introduced in mechanics in the previous course. Temperature, something that we introduced in thermodynamics, amount of substance in thermodynamics as well. What we are going to see in today's class is that there is another basic quantity that's called electric charge that's closely related to static electricity. It's closely related to static electricity, okay? Static electricity is a function of the amount of charges that you're holding. So you can become electrically charged, and the amount of charge that you carry is measured in terms of the unit of Coulomb. Here's the abbreviation, C. So here we have 6 basic quantities, and the last basic quantity is the luminous intensity. If an object is brighter or weaker, you look at an object, you look at a light source, you can make it more intense and less intense. The unit for luminous intensity is the candela, or the candle. Okay. That's how physics starts, with all those 3 basic building blocks. Okay, but here, those are scalar quantities. Yeah, scalar quantities already. Here is 2 vectorial quantities. And let me tell you what the vectorial quantities are. 2 vectorial definitions. Okay? And those vectorial definitions are very simple. You shouldn't be scared of them because you saw them. Is the position. If it's one-dimensional situation, we denote the position by the letter X. If it's a 2, 3, or 4 dimension, right? We denote the position by the vector R. The unit is the meter. And we have this other vectorial definition, which is the force. Force, and the unit of force is derived from Newton's second law of motion. That's where this unit comes from, right? Remember that Newton is kilogram meters per second squared. Where does the unit come from? It comes from one of the laws of physics. And here are the laws, some of the laws of physics that some of them you have already seen, others you didn't. 3 laws of motion, Newton's law of motion, plus the universal gravitational law. We also have 4 laws of thermodynamics. And we have 4 laws of electricity and magnetism, okay? One of these laws is called the Coulomb's law. At the end of the semester, you are going to see 2 laws of special relativity. But we are going to start with those laws of electricity and magnetism. The first of them is the Coulomb's law. Coulomb's law. Gauss's law. No, not Gauss's law. Coulomb's law. Here you go. That's the first one we're going to see. Let's just keep it this one like that. Coulomb's law is the first one. And Einstein came up with 2 laws of relativity. The greatest contribution to physics that you can make to a science is to discover one of the physics laws. That's the greatest contribution that you can provide science. Okay, so let's start to talk about the electric charge. And the electric charge is something that you have already seen in chemistry, at least in chemistry, right? At least in chemistry you have seen. And it's not that difficult to understand what electric charge is. Electric charge is not mass, okay? Electric charge is not time. Electric charge is not temperature. It's something else completely different. We needed, throughout the years, we had to create this concept of electric charge to explain the universe where you live. A massive object may have an electric charge. Let's see, every object, every physical object is made of electric charges. Okay? And there are 3 different types of electric charge. There are 3 different types of electric charge. The electron, the proton, and the neutron. Three electric charges in nature. For the sake of this, okay, for the sake, let's see, 2 types of basic electric charges. For the sake of this course, you can believe that, okay? It's not 100% true, but for the sake of this course, electric charge. Let's see how I'm going to do that. Okay, so let's go back here. There are 3 basic types of charge, right? Positively charged, negatively charged, and neutral charge. 3, okay? And there are 3 different particles associated with these basic electric charges. The electron, which is negative, the proton, which is the positive charge, and the neutron, which is a neutral charge. Okay? 3 different types of charge and 3 basic particles, 3 different particles associated with these 3 electric charges, with these 3 electric charges. So I'm telling you now, it's okay. It is okay to believe that the main constituents of matter, for the sake of discourse, okay, is okay. For the sake of discourse, to believe that the main constituents of matter are these three particles, okay? These three particles. There are more particles, but we are not going to get into that. To make things simple, just you have to believe that every matter is composed of those three particles alone: electron, proton, and neutron. Each one of those different particles has a different electric charge. And that's where I should stop for our break, okay? When we return to our break, I will show you here how we denote those charges and those particles, okay? So here we go, break. 11:51 a.m. to 12:01 p.m. No, 12:06 p.m. Okay, we have one little minute here. Is that clear? So here, you gotta have those ideas in your head, okay? To understand what comes later on. The building blocks of physics and the electric charge, the concept of electric charges, and what are the particles associated with those electric charges. So I see you in 15 minutes. I am back here. Let's go here. Okay, before we continue lecturing, let's take attendance, okay? I have to do this attendance here only for the first 2 weeks. And let's see, Miraj Abasi, are you there?
I'm right here.
Okay, thank you. You can either, use your microphone to tell me that you are present, or you can send a message via the chat box, okay? Either way works for me. Susan Acosta.
I'm here.
Thank you, Susan. Mikara Alquema. I don't see Mikara here. Let's see, someone is trying to. See here, how am I gonna get that? Okay. Right, Ryan Alquema. Is Ryan here? Hi, Ryan. Okay, I'm gonna put a star under the name of Ryan. I see him in the list of participants, but I don't hear from him. Next is Evelyn Ayala.
I'm here.
Thank you, Evelyn. Cristina Balderas Cabrera. Cristina. Hello, Cristina, are you there? I see Cristina listed here in my list of participants, but I don't hear from Cristina. I'll put a star here under her name. Ben Bendoy. Thank you, Ben. Next is Queen Castaneda.
Here.
Thank you, Queen. Emily Serna.
Here.
Thank you. Isabella Cisnero. I don't see Isabella in my list of participants. Luis Diego Cruz. Thank you, Luis. Delisha Dry.
Here.
Thank you, Delisha. Gabriela Edwards.
Here.
Thank you. Princess Gate.
Here.
Thank you. Carlo Gallardo. Okay, Carlo, I cannot hear you, Carlo, but okay, thank you. Trin Hernandez. Let's see if Trin is here. No, I don't see Trin. Next is Stefan. Stefan Steven. Thank you, Stefan. Next is Jeremy Landis.
Here.
Thank you. Paola Leones. I see Paola listed here in the participants list. Can you hear me, Paola? I'm gonna put a star under her name. Pedro Lopez.
Here, Professor.
Thank you. Jenny Maldonado.
Here.
I see Jenny Maldonado listed here, but I don't hear from Jenny. Oh, okay.
I'm here. Wait.
Yeah,
can
okay,
you
you're
hear
coming
me?
very low.
Oh,
Okay, thank you, Jenny.
sorry.
Okay, I can hear you. Thank you. Noemi Martinez. I don't see Noemi in my list. Isabel Medina.
Here.
Thank you. Kimberly Morales.
Present.
Thank you. Ramon Moran. Thank you, Ramon. Arian.
Present.
Thank you. Now, is that Oninachi, right? Is that correct? Am I pronouncing
Yes,
Oninachi?
yes. You
Okay,
can just say Oni.
Oni. Okay.
Yeah.
Is this name as an African name? I presume, right?
Yes.
Which country?
Nigeria.
Nigeria, right? Okay. Yeah, I was doing some search, and under that I saw lots of people from Nigeria with this name. Okay.
Great.
Thank you. Bye bye.
You're welcome. Bye.
Mario Shoa. Okay, I don't see Mario in my list. Ahmad Olumi. Ahmad Olumi, no. Next is Awa. I see Awa here.
Yeah. Okay.
Thank you, Awa. Catherine Perez. Thank you, Catherine. Nadia Prum.
I'm here.
Thank you. Tatiana Saldivar. Tatiana. Are you there, Tatiana? Okay, I don't think she's there. Next is Steve Sanchez. Thank you, Steve. Jason Cervellon.
Here.
Thank you, Jason. Francesca Paola Sorrentino. I don't see Francesca here. Okay. Chris Anthony? I don't see Chris Anthony either. Dana Terry. Thank you. Audrey, Tylery. Okay, I don't see Audrey listed here. Juan Torres Arellano. Thank you, Juan. Let's see how many students we have here. $27. Okay, so just 3 students that seem to be here but didn't answer. Let's see, let me give them a chance. Ryan Alkema, are you there, Ryan? Okay, the other one is Christina Baldera Cabrera.
I'm here.
Thank you, Christina. And Paola Leones. Okay, Paola must be away from her computer. Good. So I got the attendance here, and let's continue here with the topic that we are covering, right? So 3 important things, right? 3 important things to memorize. 1, the 3 building blocks of physics. 2, the idea of electric charge, which is related to static electricity. And 3, let's see. And the idea of electric charge and the 3 types of charges, right? The 3 types of charges: positive, negative, and neutral. And the 3 particles associated with their respective charges: electron, proton, and neutron. Those are the 3 important concepts to memorize. I'm talking about memorization, yeah. Just memorize it, because you have to memorize that when the scenario is going to come later on. Okay, and then we have the model of an atom. Okay. Every object, here you go. Every object is made of atoms, and every atom is made of the 3 above particles. Okay. Just remember, for the sake of this course, it's okay to believe that. It's okay to believe that we have only 3 particles. It's okay to believe that for the sake of this course. In reality, it's not like that. There is more to it, okay? But for the sake of this course, just stick to those 3 particles. In reality, there are far more particles than that. Okay, but for the sake of this course, again, just stick to this model. Okay, the model of an atom. Every object is made of atoms, and every atom is made of 3 of the 3 above particles. What's the model of an atom that works very well? 1, it has a nucleus made of protons and neutrons. Okay. And it has electrons orbiting the nucleus. That's what you have to keep in mind, right? So let me get here. Here you go. Here's my slide. That's how we represent a particle, electrically charged particle. This particle is negatively charged. Q1, and we represent by the letter Q. In this case, Q1. And that's how we represent a positively charged particle. A circle with a positive sign there inside. And this charge has a Q2, a charge Q2 greater than 0. And then we have this neutral particle, which is the neutron, with a charge equal to 0. There is a numeric value for those particles. And there is a numeric value for the charge of those particles, right? Of the electron and the proton. And there is also a numeric value for the mass of those particles as well. So let's talk about that. You don't have to memorize the actual values of the mass and charge, but you have to know something else that's simple to memorize. Okay, so let me get that. The charges of the above particles are the following. 1, electron is a negative, don't forget, is a negative charge, so consequently you must have a negative number here. And that's the numerical value of the charge of the electron. 1.6 times 10 to minus 19 coulombs. And for the proton, is exactly the same numeric value with just a different sign. Okay, it's a positive charge, but it has this numeric value, which is exactly the same as that one of the electron. And the neutron, you already know what's the value of the charge of neutron. Is 0 coulombs. You do not need to know the exact value, numeric value of those two charges, but you do need to know that one is negative and the other is positive. And this one you have to memorize. That's not difficult to memorize that, right? Neutron has no charge whatsoever. Neutron has no charge whatsoever. What else? What else you have to know? Let's see here. You also have to know their masses. Okay? The masses of the above particles are the following. The masses of the above particles are the following. And I am going to insert equation. Mass of the electron, I'm going to put like that. Mass of the electron, okay? We have a value of the mass here. I myself don't memorize those things. You don't need to memorize either, but you have to know something else. Then we have the mass of the proton. And then you have the mass of the neutron. Okay? What their numeric value? You can look at the internet. You can look at the book. Like I said, you don't have to memorize their exact value, but you have to know the following. Okay, you have to know that the mass of the neutron is greater than the mass of the proton, which is greater than the mass of the electron. Can you memorize that? The electron is the lightest one of all. But even better, I'm going to go further than that. You know, the mass of the neutron is slightly more than the mass of the proton. Okay, so how do I going to represent that? We're going to represent that. We do not have a symbol to represent it, just slightly more. Let's see if it's approximately, but don't forget it's greater. Just a little bit more than the mass of the proton. And there is more. There is more. The mass of the proton or the mass of the electron or the mass of the neutron is 1,800 times more than the mass of the electron. Okay, can you remember that? It's easier, right, to memorize it as approximately 2,000 times. Okay, that's easier to memorize 2,000 times, right? But to be more precise, should be 1,800 times more. The mass of the neutron and the mass of the proton is approximately, let's put it approximately here, 1,800 times the mass of the electron. That you have to memorize. And now let's take a look at those numbers. We're going to look at the internet. Mass. Oops. Mass. Oh gosh. Hey, I don't want it here. I want it here. Mass of the electron in kilograms. Want everything. Okay, here you go. We have it. Here you go. See, a table is the mass and the charge. Mass and electric charge are different quantities, okay? So let me put aside, and I'm gonna copy 1.602 times 10 to minus 19, no, 10 to minus 31. kilograms, okay? That's the electron, the lightest of all. Proton. Proton is minus 27, 1.67 minus 27. Okay, this one here is saying that the mass of the neutron is the same as the mass of the proton. Okay, that's not true. It's just slightly more than the mass of the proton. Let's see if we can find a better number for the mass of the neutron. Let's see. Image. I don't want image. Mass of the electron. Let's go at mass of the neutron. Neutron, Wikipedia. Yeah, maybe. Let's see. So it's possible that. Let me double check that, Jeremy. Why my internet is behaving so badly? Okay, let me see if I can get that here on the book. Coulomb's law. Title page, fundamental constants, right in here. What's going on here? Can you hear me, folks? I'm thinking that maybe I'm losing my connection here.
I can hear you.
Okay, good. Wow. My goodness, what's happening here? I'm losing. Let's close it. What about here? That's wrong. Let's try it again. I do not know what's happening here. Let me close this one. Let me close this one. And you go. Yeah, I lost my connection with Wiley Plus. Let's see. Okay, good. Oh, here you go. Okay, see the book. 9.11. I think it's something else. Jeremy, 9.11 must be the constant K, I believe. Let's see. No, it's not the constant K. 9.11. What is 9. Okay, is the mass of the electron. What did I put there? Oh, yeah, okay. 9.11. Here you go. 10 minus 31. 9.11, yeah. And now mass of the neutron is just slightly more than the mass of the proton, 1.674. 1.674. Let's see. Okay, yeah, here you go. 9.11. Okay. Here you go. Let's see. Let's go back to that one. Yeah, see? Yeah, it's close enough, right? But there's still a missing decimal place here for this one. And the missing decimal place is that one that you saw. 1.7. Neutron, 1.674. 1.674. 1.672. Okay? 1.674, 1.672. Should be 1.675 if I'm going to round it up. 1.673 if I'm going to round it up. Okay, here you go. Like that. They're almost the same. And if you do the math, you're going to see that this mass here is almost 2,000 times less than the mass of the neutron and the mass of the proton, okay? You don't need to memorize, like I said, you don't need to memorize the exact numbers, but you have to know what's listed here. What's listed here. And if we put in a table format, let's put that in a table format. Insert 1, 2, 3. Let's see. 4. One more. Yeah, here you go. Electron. Proton. Neutron. Okay, mass and charge. Here you go. Mass. This number here. This number here. And this number here. You got this number here. this number here. And this number here. Like that. And then we can both face this one and both face this one. Okay. So notice that mass and electric charge, they are completely different quantities. Don't mix up one with the other. We create this idea of electric charge because we do observe an electric force among charges. That's why we came up with this idea of electric charge. To 11, oops. Yeah, here you go. Okay. Oh, one more thing that you have to know. And don't forget, mass is a property of the matter, right? Mass is a property of the matter. And so is electric charge. The matter has those two properties intrinsic to it. Now we can go back to our PowerPoint. You go. Okay. Now, a neutrally charged object, which is, so we have those particles, those infinitely small particles. And every large object is made of those infinitely small particles, okay? Every object is made up of these three infinitely small particles. Okay. So a lump of iron, for instance, a lump of iron is made of several atoms. Is made of a very large number of iron atoms, right? And each iron atom, and let's say is made up by a given number of electrons, protons, and neutrons. Okay, and then I'm going to be even more specific. A very large number of neutral iron atoms, of neutral iron atoms, very large number of iron atoms, and each iron, let's see how I'm going to do that. Each very large number, okay, let's put neutral iron atoms, and each neutral iron atom is made of a given number of electrons, protons, and neutrons, right? And how many electrons, protons, and neutrons, for instance, an iron atom has? You gotta look at it. You have to look at the periodic table. Okay, let's take a look at the periodic table. Iron atom. Here you go. How many electrons, protons, and neutrons has a given iron atom? Okay, atomic number 26, right? The atomic number 26, what is the atomic number 26? Is the number of what? Proton 1.673. Yeah, I put 1.673 for the proton, okay, because there was the fourth decimal place was greater than 5. Okay, Jeremy? But let's go back here. Atomic number 26. Right? What is atomic number 26? What is it? Let's write it down. Just you should know that, right? What is the atomic number? The atomic number represents what? Is the number of protons in the nucleus of an atom. Okay? That's what the atomic number is. So for the iron atom, proton is gonna be 26. Since we are talking about a neutral iron atom, the number of electrons is going to be 26 as well. And the number of neutrons is going to be close to 26. Most atoms are like that. The number of neutrons is almost the same as the number of protons, but it's not always the same, okay? Let's take a look here. What is, now we have to, the mass number. What's the mass number of the iron atom? What's the mass number of the iron atom, right? Mass number is 55,845. Okay, 55,845. What does it mean? It means that 55.845 minus 26 is going to be the number of neutrons, almost the number of neutrons. It's going to be something like, let's see, 29, right? Yeah, 29, around 28. Around 28. Why is that? No. Oh, God, what happened here? Oh, gosh, my computer is misbehaving here. I don't know why. Windows, oh, I didn't ask you to do that. No, thank you.
Welcome. You've got mail.
I didn't ask to get into AOL. Here you go. 55 minus 26 should be 29, right? 29, yeah. So it should be around 29. It's just a little bit more. Why is just a little bit more? Because the neutron is a little bit heavier than the proton, right? Than the proton, right? Iron. So here you go. Approximately. How many? Let's write it down. How many neutrons are there in the iron atom? How many neutrons are there in the iron atom? Iron atom. Here you go. It depends on the type of iron atom. Remember, right, that we also have iron atoms that are slightly different from each other, right? And atomic number 26, he's saying here has 30 neutrons. Okay, but there are some, here you go, 30 neutrons. It also depends on the iron atom because there are iron atoms that are slightly different, that have a little bit less neutrons than others. And that's what the isotope is all about, okay? So, but the most abundant iron atom is the one that has 30 neutrons. And this number 30 plus 26 is 56, a little bit more than the mass number of the iron atom. And then you have the same thing for other atoms there in the periodic table, okay? From those numbers, you can calculate more or less what is the mass of the atom. What else you have to know? Here you go. The atomic nucleus, right, is very small compared to the size of the atom itself. It's more like a point particle, the atomic can be modeled as a point particle, the atomic nucleus. That you have to know as well. And here you go. And here you go. Here's an object. An object that neutrally charged is an object that has the same number of negative and positive charges. That's what it's all about. So your piece of iron, for instance, right? If it's neutrally charged, it means that the number of protons is equal to the number of neutrons. We're almost go. Positively charged object. A positively charged object is an object that has more positive charges, more protons than electrons. Okay, and negatively charged object, the same thing, positively charged object. Here you go. That's one example, positive charged object. Here's another one. This one has 2 protons. This one has 1 proton additional, right? Neutral, positively charged. What about this one? Here you go. 2 electrons more. This is a negatively charged object, and so on. Electric force, that's what we want to talk about now. Okay, and then we can talk about that when we go. What time is that? Oh, we're almost over. Okay, 5 more minutes to go. So let's get those 5 more minutes to talk about the electric force. Okay, so a particle that is negatively charged and a particle, if it's placed nearby another particle that's positively charged, we are going to see that there is an attractive force between them. What you see right in here is my free body diagram. The free body diagram applied just to my negatively charged particle. This particle is being attracted towards the other. And this notation that you see right in here means what? Force that the particle 2 applies to particle 1. Okay? Particle 2, which is the positive particle right in here, force of particle 2 applied to particle 1. And then you can do the same thing for the other particle. You can apply the free body diagram for this other positively charged particle, and the force is going to have a similar notation. Force that particle 1 exerts on particle 2. Okay? So those 2 particles are interacting with each other. And when 2 particles interact with each other, you go back to Newton's third law of motion, right? When 2 objects interact with each other, or when 2 particles interact with each other, the force that one applies to the other is equal in magnitude and opposite in direction. That's exactly what we have here. So Newton's third law of motion applies to the microscopic world as well. Okay? Whether you have an attractive force between those charges, or even a repulsive force between those particles. We put a positive charge next to another positive charge. Now the force is going to be repulsive. Okay? And again, we have that same Newton's third law of motion is going to say that this force here is equal in magnitude to this force, but opposite in direction. And that's what we have right here. Here the vector position of one particle with respect to another one, okay? And 2 more minutes to go. Let's write that down there. Okay. If you put one charged particle next to another one, they will experience an electric force. It is this electric force, it is this electric force that keeps particles and atoms together that keep particles bound, that keep particles bound in an atom, okay? And the atoms bound in a molecule. It is this electric force. Okay. The force is attractive for particles of opposite sign and repulsive for particles of same sign, okay? And because the neutron does not have any charge, it does not feel any electric force from a proton or neutron, okay? And what is the equation for this electric force? That's what we call Coulomb's law, the equation for this electric force. I'm gonna get here the equation. Okay, is given by this equation. It's very similar to the equation of the universal law. It's already 12:51, okay? So the good spot to stop. When we meet again on Wednesday, we're gonna lecture for 1 hour and I will elaborate more on this equation, okay? So we are going to have office hours right now. If you want to hang around and ask me questions, I'll be around. I see you.
All right, thank you, Professor.
Professor,
Thank you, Professor.
Thank you.
will this be uploaded, Professor?
Yeah, I will upload this note.
Okay, thank you so much.
Okay, welcome. Deixa eu ver se someone's trying me here. Let's see, Jason. Thank you, Jason. Let's see, Mikara is here. Okay. You want to ask a question,
Thank you,
Mirage?
Professor. Yes, thank you. Wow.
Okay, let me approach a little bit more your mic because I can hardly hear you. Come closer to him.
Is this better right now?
Yeah, it's too low. Let's see. Let me raise my volume here instead. Go ahead.
So about you were talking about patenting your inventions earlier, and it caught my ears. I've been trying to do the same thing a couple of times with different different things that I've been working on. And I've been hitting what is it called, a plateau in getting it all done.
Okay.
Still don't know what is the best way to make this happen. I have the basic understanding of what patenting is and how it's done. But as advice, it's a very expensive way to do it. Do you have any perhaps any tips for me in this matter, like how to approach it? What is the best way?
Okay, so the first thing that you have to be careful, right? You cannot disclose publicly your invention. That's the first thing you have to be careful, okay? Do not publish a paper. Do not keep on telling everybody about your invention. Do not say in public. It's okay to tell your lawyer, okay, or a trusted person. That's the first thing, because once you disclose it to someone, you have only 1 year to patent, to file a patent, okay? That's the first thing that you have to be careful about, okay?
Correct.
And Okay, now the best way to patent an idea is not to file a regular patent yet. In the United States, we have something else that we call provisional patent application. Okay,
Correct.
that's that. Are you familiar with provisional patent application?
To an extent, yeah.
Yeah, because there is the provisional patent application, then there is the regular patent application, right? The regular patent application is expensive. The provisional patent application, I believe, is costing something around $200 only. Okay,
Correct.
yeah, and the provisional patent application, we call it PPA, right? PPA. It has been a long time, but I think it's around $200.
Yeah, I've done this once.
Huh?
I've done this once.
Oh, you have done this once, okay. But the only problem about the PPA is that you after 1 year, you have unless not after 1 year, unless this PPA lasts for 1 year. Here you go. PPA lasts for 1 year, and before its expiration, right? You either renew your PPA or you file for a RPA, which is the regular patent application. Okay.
Correct.
The regular patent application, and that's going to be your first patent, right?
Correct.
Okay, good. So if you go in the site of the
sorry to interrupt you. I have one PPA right now.
yeah, okay.
It's almost up, which most likely I have to renew it because I don't have the money to do the RPA. And I have two other things that I'm working on, which I have to perhaps do PPA on. So.
Okay, the first PPA, when it's going to be 1 year after you file?
In 2 months.
Oh, in 2 months. Okay. Okay, so if you are 100% sure that nobody else has patented your PPA, you can renew your PPA, your first PPA, okay? But only if you're 100% sure nobody has discovered the same thing independently of you, okay?
So, question. So when I do the PPA, and someone else comes up with the same idea and do the RPA on it, the whole patent's for them?
Well, it just depends when you file your PPA, when he filed his RPA, right? And whether you convert your PPA into a regular patent or not. Okay. If you file your PPA before the other guy filing his RPA, you have priority. Okay.
Understood.
You file in 1st of January 2026. The guy filed his RPA on the 2nd of January 2026. And one more detail, he did not file a PPA. Okay. This guy that filed 1 day after you, he did not file a PPA. He just went straight to the RPA. You still have the priority. But on the 1st of January 2027, if you don't file your RPA, then the guy is going to have priority over you. Okay?
Oh, okay.
The PPA is what we call the first date.
Almost like a landmine.
Yeah, priority date. We call it priority date.
Correct. Understood.
The priority date. So your priority date is 1st January 2026. The other guy's priority date is 2nd of January 2026. Right?
Understood.
But
what if I renew my PPA?
What if you? If you renew your PPA, then your priority date becomes that date that you renew the PPA. Okay? If you renew
the guy who did the RPA still has the second priority.
And then the other guy that filed after you, right? Before your second PPA will have the priority over you. Okay? Because once your first PPA expires, you lost the priority. And the new priority is going to be the second one that you file. Okay?
Okay, understood.
But if you file your regular patent application 1 year after, that priority date of the provisional patent application still applies, okay? If you convert your PPA to an RPA, it is the priority date is going to be the priority date of the provisional patent.
Okay, cool. Cool. What else is there that you could share with me?
No, that's I suggest that you look for an attorney, okay, to help you out. I think it's gonna depend what you wanna do. You wanna file just in the state or you wanna file around the world, right? Most likely you want to file just in the States, right?
Correct, yeah.
Yeah. If
The
you
rest
file,
of the world, they don't work on patenting that well. Everybody
yeah, that's
steals
what.
from each other.
Yeah, that's why you have to consult an attorney, right? Attorneys help you out. You show the provisional patent to the attorney, and he's going to tell you how they can draft the regular patent application for you.
Understood.
And let's see what are the fees. Let's see what are the fees, patent fees, right? Here's the USPTO, right? Can you see my site? Patent fees. Let's see. It has been a long time I don't file regular patent application, and I forgot what is the fees. Search for patent, search for trademark. I presume that the regular patent application is around $1,000, right? Is that how much it is? Do you know what are the fees?
For regular patent, I
Yeah,
think last time I checked, $1,000? No, it's a lot
$1,000.
more.
Okay,
Way more than that.
regular patent application. Let's see application. Application filing. Application fees. Let's see.
Oh,
Trademark.
just the application fee,
Yeah, just the
not
application.
setting up the application.
Yeah, it's just the application fees, not the attorney. The attorney is going to charge you more. Okay,
Oh,
see
yeah.
provisional patent application fee.
Right.
Oh, see that?
Mhm.
Micro entity 65. Now it's 325. In my time, the fee was 120. So they already small entity
The whole
130.
patenting that I did for my first one that I wanted to do for my first one, they gave me an estimate of $25,000.
25. No, it's not that much. It's not that much. I don't know.
Yeah.
Yeah, it's an attorney may make you think that's gonna cost you $25,000. Okay, many attorneys they like to play this type of game. Tell you that's gonna cost it. At most $5,000. I'd say with the attorney. An attorney may charge you like $2,000 to file in the States. Okay, and then let's see the regular patent application utility must be this one here. 450. Yeah, I see 450. I thought it was more than that. Utility application. Okay, 450. And if you are a micro entity, you pay just $90. You might
What is a
be
microentity?
what?
What is a microentity?
Micro entity, they have this definition, right? Small entity is small business. Micro entity, is a small business that has just a given number of patents issued. I do not know what the very definition. Okay, I don't qualify as a micro entity, but maybe you do qualify because you do not have any patent issue, do you?
No, I don't.
Yeah, most likely you do qualify for a micro entity. Okay, so you got
The
a
utility application is for a device.
Yeah,
And
that's
the
right.
design is an idea.
I do not know what design application is because I never got involved with that.
Yeah, you were mainly doing utility, right?
Yeah, I do mostly utility. Yeah, utility patent application. See the provisional patent here. Provisional
Correct.
application size fee. 450. Okay, it's the same. It's the same price, the provisional from the utility. Huh, interesting.
Oh.
Yeah, see, that's the same price, right? The provisional and the utility. I'm surprised. But it depends also the number of sheets, right? And must depend also on the number of claims as well. But it looks like you're doing the right thing. You filed a provisional application. Did you write the provisional yourself, or you paid an attorney to do that?
No, are you familiar with the Minds to Paper website?
Uh-huh.
There's a website that actually like does what is it called? Does a drawing of the device. It does the patenting for you, like you know the
Really?
written part, and it actually like gives you evaluation whether this device is
Patentable or not?
going to. I'm sorry.
Patentable, whether the device is patentable or not, right?
That's one of the evaluations. The other one is like whether this device has the chance to uh, get invested on.
Uh-huh.
And then I used that, and I actually paid $300 to them.
An additional 300. Okay.
Yeah, an additional $300 plus the fees for the application, which at the end of it, it was like around like I think it was like $700 or $900
Uh-huh.
that I spent on it.
Okay.
So yeah, I know I made a mistake on that for
Uh-huh.
sure.
A provisional patent application is not difficult. Okay, I just file on my own. I don't hire attorneys to file my provisional application. I only hire an attorney to file my regular patent application.
Test. Okay.
Professor, I'm so sorry to interrupt.
Okay, go ahead.
I'm sorry. I have questions regarding the class, if that's
Uh-huh.
okay.
Okay, go ahead.
Sorry, I sent you an email in regards to not being able to attend the lecture and labs. I think you responded.
Yeah,
I know you mentioned you wanted me to at least make sure that I have a lab partner.
yeah.
Oni, she's also on the Zoom currently. We have been texting back and forth, and
Okay,
she's agreed to be my lab partner for Physics
okay,
7.
okay.
So I
What's
was
her name?
wondering if Oni, she's on the
Oni.
Zoom as
Okay.
well.
Let me write that down here. Just make sure you attend. You know, it's okay not to come to the lab nor the lecture. It's okay, but during the exam you must be present. Okay, you must
Oh
online.
yes, I
Fine.
will
Okay.
be. I will
Yeah.
definitely be present for the exams and the final.
Okay. So let's see. Group here.
I just don't want you
Group.
to drop me.
No, no. Let's see.
Uh,
Dry and
Sorry to interrupt.
let's see. And Oni, right? What's her last name?
We will.
Oni. New. Okay. I'll put you as group number 1. Okay.
Okay. And I had a question about how the homework works. Will I get like let's say notifications about the homework, or like you said it's a website. I already logged into the website and created my account. But like how can you just give me a summary of how it works? Will I get notifications on when due dates and stuff, or
Yeah. The due date of the first 2 homeworks is in March. Okay. The site will not advise you when the homework date is expiring. Okay, so you have to, let me see here. Here you go. See that homework 1 is due March 23rd. Okay, and
okay?
homework 2, let's see, is due March 24th. Okay, so I still
And
have to post the others.
that's in assignments, right?
Yeah, that's already assigned homework. Yeah, that's already a homework assignment.
Okay, and I
It's on the
received.
Wiley Plus website, not on the Canvas.
Yeah, it's not in Canvas. It's the Wiley Plus website.
Okay, cause I already created the account and stuff. I just wanted to ask how, yeah. Okay, so I have to log in every single time to check the. Okay,
Yeah. Uh-huh.
no,
Do you
no
already have
problem.
an account on Wiley Plus? Do you already have an account there on Wiley Plus?
Yeah, I created it during class. So
Okay,
yeah,
okay, good. So let me
okay,
see. Most likely you're already here. Let's see here.
right, okay,
Let's see.
all right.
People. It's taking so long. Okay. Yeah, for some reason this site is low, but yeah. Any other questions?
No, that was the only question I had.
Okay, good.
Sorry, if we still have a Wiley Plus account from the Physics 6 class, do we use that one or do we create a new one?
Let's see. You have to create a new one because you have a new course ID, right? You have a
Okay,
different
got it.
course ID. So if you bought 2 semesters of if for the Wiley Plus, you should be able to use it this semester. Okay, but you still have to create a new account.
Okay, got it. Okay, I just wanted to make sure. Okay, so you are assigned our group for me and Oni.
Okay.
Do you need anything else from me since I won't be able to participate in the Zooms this semester?
No, that's just make sure don't miss the exams, right? And be in
Right.
constant contact with
Okay.
Okay, and submit and I'm going to assign the links,
Okay.
right, for the group for
Did he
the
freeze?
lab
Did
groups.
he freeze? He froze.
Yeah.
The lab groups. But I'm gonna do that on Wednesday, not now.
Your name is Delisha?
Delisha, right? Delisha or Delisha, your name?